Hello guys, welcome back to my channel. Mason African Motives still working on mathematics and two. So in this platform we shall have a continuation working on the question paper which was actually written in March 2018, which is actually an X paper. So we shall quickly rush through the question and see what we were given in this platform. And as we know, the guys, the instructions and the information will be clear. Your numbering system and your final answers to 3 decimal places, and also make sure that whenever you are writing, you are supposed to present your work nicely and it's supposed to be clear. Each and every step that you're supposed to take should be clear. All right, so let's just see what you're given on the first question. They were given to simplify without the use of a calculator. So actually, I think I talked about these typical questions where you'll be given a condition not to use a calculator. So let's just see what you are given on the first place here, the application of the exponents and so forth, and which laws can we actually apply. Take note, the first part we are given an exponent and another exponent, and we have the law which states that x to the exponent of a to the exponent of b, you're going to multiply the exponents. So that actually means that in this case we can end up multiplying the exponents in this case, which is 6 and 2, because we've got 6 and 2 there, which is going to give us 12. All right, so that's gonna give us x to the exponent of 12 there by let's see this part. We have an exponent, we have got two terms, but everything is being affected by the exponent of 4. That's something like this: x to the exponent of 3, y to the exponent of 1. We do not have the exponent, so it's same as 1. It's not written, but it's same as 1. Then everything to the exponent of 4 like this. So still this 4 is going to do the same thing. It's going to multiply this and it's going to multiply 1. So it's going to be at the end 4 times 3, which is 12. So that's going to be x to the exponent of 12, y to the exponent of, that's 4 times 1, which is 4 like this. So that's what you're going to have. Let's see another part again that we are given here. This time we have a negative 3 on our exponent there. So it's like this: it's x to the exponent of 1, y to the exponent of 0 like this, to the exponent of negative 3. So actually you're going to have the same thing, negative 3 times 1, which is negative 3. So this is going to be x to the exponent of negative 3 by negative 3 times 0 here, which is to the exponent of 0. As we can see that that one do not have an effect, or you can just write it as 1. Still there's no effect. We'll see that one later on. Then in the denominator here we've got the same case again, to the exponent of 3. So it's x to the exponent of 2, y to the exponent of 2 to the exponent of 3. So it's the same thing. 3 will multiply 2 and will multiply 2 here, so it's going to be x to the exponent of 3 times 2, which is 6. 3 times 2 again, which is 6. So it's y to the exponent of 6. Okay, times the last part is just xy like that. This one is just xy. So this is like this, what we have here. So what are we going to do here, guys? Let's take the numerator first on top here. What do we have here on top? So here we are multiplying so the bases are the same, so you can actually add the exponents, which is going to give us x to the exponent of 12 plus 12 plus minus 3. So we add the exponents together like this, which is the same thing for y there, by y to the exponent of 4 plus 0 there, of which 4 plus 0, that's a 4. Or you can just say this is same as 1, so it's 1 times this, which is y to the exponent of 4. As you can see, there's no effect or there's no change there. We have the same thing here. We are multiplying, so you're gonna add exponents, so this is the same as to the exponent of 1, so it's going to be x to the exponent of 8, 6 and 1, that's 6 plus 1 times y is the same here to the exponent of 1, so you add 6 and 1 like this. All right, so what are we going to have at the end? If we add everything, this is going to give us 21, because you're going to obtain 24 minus 3, which is 21. So it's x to the exponent of 21 like this, times y to the exponent of 4 plus 0, which is 4, everything over 6 plus 1, that is 7. So you've got x to the exponent of 7, y to the exponent of 7. So you can just put this, but it does not have any effect now. All right, then these two are actually dividing each other, these two. So this time we are going to subtract the exponents, because we are dividing this time. Remember, x to the exponent of a over x to the exponent of b gives us x to the exponent of a minus b. So this time we are going to subtract the exponents there, which is 21 minus 7, that's it, which is x to the exponent of 21 minus 7, guys, this is what, this is 14. Okay, then y is the same also, it's 4 minus 7, which is minus 3. 4 minus 7 is minus 3, so it's x to the exponent of 14, y to the exponent of negative 3. So you do the same, these two here, they are dividing, so they subtract 4 minus 7, which is negative 3. But this is having a negative exponent, so what am I going to do? Remember, anything to the exponent of negative can be written as 1 over like this. So that can be x to the exponent of 14 over y to the exponent of 3. You can write this in the denominator like that. So that is what we are going to have at the end if we are to simplify as far as possible. If we are to simplify in simplest form. So guys, we have to be very, very careful with the type of working that you'll be given. Anyways, let's see another question that we are given there. It's on 1.12. That's the logarithm of 64 in base 4. So this is actually in base 4. All right, so I'm opening this earlier. It's supposed to be later on. Okay, anyways, this is 1 over 49 in base 7, like this, everything to the exponent of 3, then everything to the exponent of negative 1. All right, guys, let's just see how and what were we supposed to do in this type of equation. So actually, remember, you're not using a calculator here, so you can maybe try and simplify this into a simpler version. Remember, I always talk about trying to write something of this nature is the best, to have the logarithm of a number and the base of that number, because we know that it gives us a 1. So it can only be a matter of these two numbers being the same. only. So that's 64 and 4. So already we have got a guidance, which is this base here is going to be our guidance. So which means we are going to write this 64 in base of 4. So this will be 4 to the exponent of 3. But this one is in base 4. So take note, guys, we need to write 64 in terms of what? In terms of 4. So we say this is to the exponent of 3 like this. So we haven't changed anything because 4 to the exponent of 3 is 64. Alright. Still remember I've got my exponent of 2 here plus 1 over 49. We can apply our laws of exponents here. It's 49 to the exponent of -1, which is in base of 7 is going to be 7 to the exponent of -2, because 49 is to the exponent of 2 times -1, so that will be -2 because we want this in terms of 7. So it's going to be log 7 to the exponent of -2 in place of 1 over 49 in base 7 like this, but everything to the exponent of 3 and everything to the exponent of -1. So it's another stage at least that we have completed. Now the stage that we actually need here is almost there of writing this, but this time there is an exponent, so you have to remember I told you that you have to drop this exponent so that it will multiply the log. So this will be 3 log 4 base 4 from this law of p log m equal to log m to the exponent of p. So that's gonna be 3 log 4 base 4, but everything to the exponent of 2 like this, plus we do the same, we drop this, so it's gonna be -2 log 7 base 7 like this, everything to the exponent of 3 and everything to the exponent of -1. But the stage here is now clear. Remember we said this will give us a 1. So whenever I see log 4 base 4 like this, I know this is same as 1. So it's same as 1 times 3, which is 3 to the exponent of 2, plus -2 times log 7 base 7, which is same as 1. So this is same as -2 times 1, which is -2 to the exponent of 3, but everything like this to the exponent of -1. Alright, so that's another stage actually. 3 to the exponent of 2, as we can see, this is 3 times 3, which is 9, plus -2 to the exponent of 3, which is actually going to give us -8, and everything to the exponent of -1. So adding these two, we are going to obtain a 1. 9 plus minus 8 is 1. So that's going to just be 1 to the exponent of -1, of which we know to the exponent of negative means 1 over, of which does not have any effect because 1 over 1 is same as what? Is same as 1. So guys, as you can see, that was the struggle there. That was the struggle there. And if you had to cross check, it's nothing, it's actually nothing there. It's just a matter of applying the laws. You have got the laws of logarithms and the laws of exponents. It's now a matter of applying those laws together. A combination of laws applied together can actually work something out. Okay, so let's see another one which had 4 marks again, to simplify without the use of a calculator, which was actually, this was 1.13. This time we had log 5 base 4 plus log 1 over 10 in base 4 minus log 2 base 4. So this is log 4 base 2. So that is 4 marks for this. And if we are to cross check here, we are going to see that
here we have got the bases which are actually the same here, and we are adding. So we know that when we are adding and the bases are the same, we can actually multiply the numbers. Log a plus log b gives us log ab, provided that the base is the same. So in this case we are in base 4, so we can actually multiply the 2, which is 5, times 1 over 10 like this, everything in base 4. So everything will be in base of 4 like this, minus log 4 base 2. Take note here, this base is not the same as this one, so that is why we have to leave this aside. So let's multiply and see 5 times 1 over 10. This is going to give us 1 over 2, which is a half, in base 4, minus log 4 base 2. So actually at that stage, there are so many ways of calculating this question. There are so many ways of simplifying actually this question. We can make the bases to be the same, but that would be something else. We can actually simplify this separately, obtain an answer for this, then simplify this separately. So that is what you're going to do. So what do we obtain from log 1 over 2 in base 4? How do you simplify this? Remember, this is the same as we can write this as log 1 over 2 in base 2 over log 4 in base 2. Remember, you just need to write in a simpler base, of which you can use base of 2 like this. So that is from our laws of exponents. 1 over 2 is same as 2 to the exponent of negative 1. So we can have this as log 2 to the exponent of negative 1 like this in base 2 over log 4 in base 2 is same as 2 to the exponent of 2 in base 2. So remember, at this stage you have to drop the exponents. So it's going to be negative 1 log 2 base 2 like this, over, you drop also this exponent, is going to be 2 log 2 base 2 like this. So as you can see, actually this here and this here are the same, so which means our answer is just going to be a direct negative half. So that is what we have. So this is from log half there. Remember, we are not allowed, the calculator is not allowed, so we have to go through all this process. So we are going to obtain negative half from log half base 4, this one. So this one gave us negative half, minus log 4 base 2. So this one we can actually just do it here. This one can be written as 2 to the exponent of 2 in base 2. So this one is direct, we can just drop the exponent here, which is 2 log 2 base 2. But remember, 2 log base 2 base 2 log 2 base 2 is 1. So it's 1 times 2, which is 2. So it's going to be negative 2 like that. So we are going to have negative half, negative 2, which is something like negative 5 over 4, 5 over 2 as a fraction. So this is what you're going to have at the end. So these are some of the typical questions that you're supposed to take note of, or to consider very, very much, because they can ask something in that manner or in such a way. So you have to be very, very careful. Then so for x, still on question 1, which is 1.2, there we have got 10 into 1 over 32. That is according to what I'm seeing here. I don't know if that is actually it, but okay, let's see what you're going to have here. Remember, I want to solve for x, so let's just get rid of this 10, because I don't see any use of this 10, because it can't be multiplied direct here. It's it's wrong, so you can actually just divide by it. So you can just divide by this 10 so that we can just get rid of this. So it will be 1 over 32 to the exponent of 2 plus 3x, which is equal to 640 divided by 10, which is 664. All right, now I'm at this stage that supposed to calculate for x. So remember, if this is on the exponent like this, I can make sure that the bases are the same. So at least I can try to write these two numbers in the same base. So let's just start by writing 1 over 32 first. Let's just try and simplify this. 1 over 32, you know, is 32 to the exponent of -1. So we have got 32 and we've got 64. So which base can we use? This can maybe, let's go to base 2, because 2 has got something common, because 32 is same as 2 to the exponent of 5. This 32 here is same as 2 to the exponent of 5, but there is a exponent of -1 which is there. So it's going to be 5 times -1, which is -5. So which means this 1 over 32 here in base of 2 is 2 to the exponent of -5 like this, but everything to the exponent of 2 plus 3x like this, which is equal to 64 in base of 2, which is 2 to the exponent of 6. Yes, that's 6 there, which is going to give us 64. So that's 2 to the exponent of 6. Now we are at that stage, almost there. We are almost there. Here we can but we can just take these guys direct, because as you can see, the base here and the base are the same. So we can actually just equate the exponents, which is this exponent to this exponent. But take note that these are multiplying, because this is an exponent. So you can actually maybe open a bracket like this. So it will be like this. It will be -5. You remember, we equate the exponents. We equate the exponents like this. All right, something like that. So we have to make an equation, this one equal to this one. So it's -5 into 2 plus 3x like this, equal to the exponent here, which is 6. So by doing so, you have formulated an equation where you are able to solve for x. So now you can solve for x. How? You can actually expand the brackets. So what are we going to have here if we expand these brackets? That's -5 times 2, which is -10. -5 times 3, which is -15x, which is equal to 6. Yeah, something like that there, which is -15. So we can actually transpose, which is -15x being equal to this one to this side is going to be a plus 10, which is 16. So to find x, we can actually divide by -15 by -15. So therefore our x is going to be -16 over 15. Okay, I don't know why we are obtaining such a weird value like that, but that is what we are having in this case, depending with the calculation that you've made or the way that you've taken the, but that is the consideration. Okay, given a is equal to pi r into h squared, make h to be the subject of the formula, and we've got 3 marks for that. All right, so this is actually change of subject or to transpose, where you are supposed to make one the subject or to transpose one to be the subject there. So we want to make h to be the subject here. So we just have to get rid of what is surrounding the surroundings of h. So before we get rid of the square root, let's just start by this, which is outside of the square root. These two terms, they are multiplying. So what can we do to remove this? We can divide by this pi r. so you can divide by both sides so that this can cancel. So that means these two are equal. So if A is equal to B and I write that B is equal to A, it's one and the same thing. So I can actually start by this side, which is the square root of h squared plus r squared is equal to A over pi r, like this, since we say these two are equal. Now, as the edge that I want to make this subject is actually enclosed, or it's covered by the square root, this one. And the only way to remove this square root is to introduce a square. That is the only way. So you have to square both sides. So you'd have to do this on both sides of the equation. All right, so the moment we square both sides, that's we are actually automatically removing the square root. So that's going to be h squared plus r squared, which is equal to, so take note, the square here is going to affect each and every term here. So it's a squared like this, pi squared like this, r squared like this. Each and every term is going to be affected by that squared. Now remember, we have to keep in mind what we are supposed to make this subject. It's h. Now it's not out of the, it's now out of the square root, like it's free from the square root, but still there is something that is affecting this, which is this plus r squared, which is adding this. So we can just transpose this time to the right hand side. So remember, it's a plus, so it's going to be a minus. We can transpose that. So h squared is going to be a squared over pi squared r squared like this, minus, the moment we take this with the minus, with the plus, it crosses the equal sign, it becomes a minus. So it's going to be minus r squared like this. Now h is alone, but it's affected by a square. That one, it's affecting h, because we do not want an expression for h squared, we want an expression for h, not h squared. So what are we going to do? We introduce the square root. Remember, when there was a square root, we introduced the square. So to remove a square, we introduce square root. So we introduce square root both sides like this. So this time it's square root, not square, square root like this, both sides. So the moment you introduce the square root both sides, this will automatically cancel that square. So our h is going to be, remember, we know that square root of any number is plus or minus, so you can actually write plus or minus the square root of, make sure that everything is covered by the square root, everything here is covered by the square root. So it's a squared over pi squared r squared like this, minus r squared. Make sure that your presentation is as this, or maybe if you could have done another way, your answer was going to look like this. H is going to be plus or minus the square root of a squared minus pi r to the exponent of 4 like this over pi r squared. Maybe if you could have done this in another way, it was going to look like this. But this is the way that, according to what we have done, this is what you're going to obtain. So these are two possible answers, but you can actually leave your answer at this stage. So guys, as you can see, that's how they ask these questions. Guys, as you can see, it's actually something else. Okay, on 1.3 to calculate the value of h if r is 2 and a is 150. Now we want the value of h. So here we are just going to take a positive value. What you just simply do is to substitute whatever that you are given. Our r, which is 2, and our a, which is 150, into the formula that we are given here. So remember that our h is equivalent to the square root of a squared over pi squared. So it's going to be a squared, which is 150 squared, over pi squared times r squared, which is 2 squared, that is r squared, minus r squared, so it's going to be minus 2 squared, like that. So this is something else, guys, where we just need to apply our calculator properly there. So make sure that you just open your calculator. That's gonna be 150, that's 150 squared over pi squared, that's shift pi squared times 2 squared, minus 2 squared, something like that. So which is 23.7, something like that, 23.78 931815, something like that, which is 23,789. That will be our h. So depending with the value that you'll be given there. But as you can see, that's actually what we had on this first question, which is making up a total of 19 marks. So we shall come again, still working on the same question paper, having a continuation from where we left on question 2 till we finish up the question paper that we are having. So anyways, guys, that's it from Meson African Motives, working on engineering science, working on mathematics. Actually, this is mathematics N2. You see this thing of working with a lot of subject. This is mathematics N2. Till we meet again.